I went to the eye doctor a couple weeks ago, and he got my contacts prescription refilled. So I'm back in my contacts, and they, had contacts. I don't know if y'all ever worn contacts, but they float, and I've got astigmatism. So when it floats off, and it has to float right back, everything's real blurry, and it will change every time you blink. So it's going to be an interesting afternoon, because it wasn't doing that this morning. All right, so chapter 15, IV solutions, equipment and calculations. We're going to concentrate mostly in this class on the flow rates. There's a lot in this chapter. We're going to do a lot in this chapter, but it all has to do with different flow rates. So this first part that we're doing today, I'm going to give you the definitions, or well, I've got them up here. Talk about the IV bags a little bit, but we're mostly going to concentrate on the flow rate calculations. And we work it basically the same way. It's just got a different, we're looking at different things. All right, so the IV solutions, these are the initials, initials form, abbreviations form. But D stands for dextrose, which is also your glucose. It's a real common IV that they give. W is water. S is for saline. NS is normal saline. It's 0.9% of sodium chloride. 0.9% of sodium chloride. That's the common term for normal saline, because it has the same concentration of sodium chloride normally present in the blood. Now, all this comes out of the textbook, so if you need to go back and look at it, read a little bit more. We have the sodium chloride, which is the NaCl. Ringer's lactate, the RL, and the lactated ringers, the LR. If you'll notice, they're the same thing. Okay, I don't know why one of them's called Ringer's lactate and the other one's called lactated ringers, but it's a mixture of sodium chloride, sodium lactate, potassium, and calcium chloride in water. And so I don't know if it's maybe two different manufacturing companies or what. So those are all your abbreviations, and you'll see them. I just wanted you to kind of know what they were instead of saying, okay, it's D5W. The number, and when we look at this first example, the number in between that 5 stands for 5% dextrose. If it was 7, it'd be 7% dextrose. 10's 10% dextrose. The doctor orders it as D5W. Okay. So it's a 5% dextrose. I need my pen to work. Come on, pen. There we go. So this 5% is the same thing as saying 5 grams in 100 milliliters. Anytime you take anything out of a percent, you always put it over 100. So that's where I'm getting the 5 over the 100. 5 grams in 100 milliliters. And it also says here on the label, each 100 milliliters contains 5 grams of dextrose. My little red box. That's my little red box. You don't have the little red box on the label. So, now if we go down and look at example 2, we've got, I'm going to change my color so it stands out. We've got D10W. Okay, so that's 10% dextrose in water. And we've got a 250 milliliter bag. It's an IV, and you want it ran over 6 hours, or you're going to run one every 6 hours. So it's just a small 250 milliliters. But what they want to know in this question is how much dextrose is in 250 milliliters. Okay. The 10% works the same way as the 5% as far as calculations. It's 10 grams per 100 milliliters. And then if I want to know how many is in 250 milliliters, I'm just going to multiply it by 250 milliliters. So I'm wanting to know how many grams. Calculate the amount of dextrose. So I want to know the grams. So my milliliters are going to cancel. I got a 0 here on top that I can cancel 0 on bottom. I got a 0 in the 250 that I can cancel another 0 on bottom. And that gives me 25 grams. So there's 25 grams of dextrose and 250 milliliters of the IV solution. Oh gosh, no, I said that wrong. There's 25 grams in a 250 milliliter bag. So you won't see this. I just want, as far as this class goes, I wanted you to be aware though of what it meant, what it means. You know, the 10 is 10 grams per 100 milliliters. So you can calculate quickly how many grams it's going to be in 250 milliliters or 500 milliliters or 1,000 even. Okay. So getting into what we're actually going to do today, this is the important part. It's calculating flow rates, and our flow rates, and for this, we're talking about an infusion pump, is in milliliters per hour. And to calculate it, you want your amount of IV fluid, so your amount in milliliters over your time in hours, okay? And it has to give, you know, it has to be milliliters per hour, milliliters per 1 hour. So my order is for D5W, 250 milliliters IV over the next 2 hours by infusion pump. So my total milliliters, or my total amount, is 250 milliliters, and it's over the next 2 hours. So to get my milliliters per hour, I'm doing 250 milliliters divided by 2 hours. So take 250 divided by 2, we get 125 milliliters per hour. This will be the easiest stuff we do all day. Okay. Now, sometimes, you know, if you're giving what's called an IV piggyback, what it is you've got IV medication in IV solution, and you're giving it through the IV. And it's generally a small package of IV solution, small packet. So they give you an order of ampicillin 500 milligrams IV in 50 milliliters, D5 1/2 normal saline in 30 minutes by infusion pump, okay? So as far as my total milliliters, I don't need this ampicillin 500 milligrams. Now, I need to know that there's 500 milligrams of ampicillin in my IV packet, but for calculations, I don't need it. So my total milliliters is 50 milliliters. My total time is 30 minutes. And I'm wanting milliliters, remember this, you're wanting milliliters per hour. So 50 milliliters, because we're setting the infusion pump over 30 minutes. Since this is in minutes, I've got to convert it to hours. So there's 60 minutes in 1 hour. Okay, so my minutes will cancel, leaving me milliliters per hour. Now, you can multiply 50 times 60 and divide it by 30, but I know 30 goes into 60 2 times, and that makes it easier for me to multiply. So 50 times 2 will give me 100 milliliters per hour. Okay. Okay, we okay so far? All right, so number 5, you're going to work it the same way, except we've got a different conversion to use. So it's in liters, 2.5 liters in 20 hours. So I'm looking for milliliters per hour. I can still put it as 2.5 liters over 20 hours, but since I want milliliters here instead of liters, I've got to do the conversion. So liters on top, liters goes to bottom, milliliters will go on top. So how many milliliters are in a liter? 1,000. So 1,000 milliliters, 1 liter. So now my liters cancel, and I'm left with milliliters per hour. I'm going to cancel this 0 with 1 0 up here. And then I get 2.5 times 100 gives me 250 over 2, because I canceled that 0. 250 divided by 2 is 125 milliliters per hour. Now, I mean, I'm sure you've been told, and you'll be told again, that the infusion pumps for the IVs, all you have to do is type in there your number of milliliters over your total time, and it will set the pump. There's not a 2.5 liter bag that I know of. They're all, the biggest one I know of is 1,000 milliliters. But this 50 milliliters in 30 minutes, you could probably type in as 50 milliliters, 1/2 hour, and it would figure it as to 100 milliliters per hour. But what happens if instead of typing 50, I got big fingers, I don't know how big those pumps are, the numbers on those pumps, but you hit 40 instead of 50. Or, you know, you hit, instead of 50, you might hit 52 and get 52 milliliters. Still over a half hour. It's going to be off. It's going to flow either too fast or too slow, depending on what you hit. So if you know how to calculate it in your head, you can always make sure you've got the right rate on your infusion pump. So you've got to know how to do it, even though the pump will do it for you. One thing that the pump will not do is if we do gravity flow. So you've got infusion pumps, and then you've got manually regulated IVs. These are called gravity flow. These don't go through pumps, okay? These are calibrated, these are calculated, or no, I'm not using the right word. It's got to be the headache. You set these based on a drop factor, which is based on your IV tubing, okay? So you've got some IV tubing that's got a wider diameter than others. The wider the diameter, the bigger the drops you'll have. So we calculate it based on our drop factor because of the IV tubing. The flow rate here is drops per minute, okay? Because we're going to count the drops. GTT stands for drops. I don't think I have that up there. So GTT, and sometimes my GTT looks like GH. That stands for drop, or that represents drop. It's actually either the Greek or Italian. I think it's a Greek word. It's an abbreviation of the Greek word for drop, because most of our medicine comes from the Greeks, I think, or Latin. I used to know that. I used to know that. All right. So it's the number of drops falling per minute into the IV drip chamber. It's counted and regulated by opening and closing a roller clamp. So that roller clamp can move. Anyway, you're going to be the one to count the drops. And it's referred to as a watch count. All right, so our drop factor is our GTT per milliliter. It's used to calculate the gravity flow rate, depending on the IV tubing, is what I was talking about. So we have our micro drops, macro drops, which means large. Macro is a large amount. So we can have 10 drops per milliliter, 15 drops per milliliter, and 20 drops per milliliter. That's 3 different types of IV tubing, okay? Then we have our micro drip. Micro meaning small. So our micro drip, which is our smaller drops, there's 60 drops per milliliter. It's also known as a primary IV set. So you might see micro drop, you might see 60 drops per milliliter, or you might see a primary IV set used, wanting to know for the micro. So just know that a micro and a primary IV are both 60 drops. Now, to calculate the drops per minute. So to calculate, drops per minute, it's got to be per minute, because you're not going to want to sit there and count the drops per hour. 60 minutes is a little too long to be counting drops. So it's still the amount of IV fluid in milliliters over your time. This time, not time in hours, but time in minutes, times your drop factor, which is your DTT, over your ML. And if your time is given in hours, then you'll want to use a time conversion, 1 hour, 60 minutes. Okay, so this last hint is if we need it. And most of the time, you will need it. The only time you wouldn't need it is if you were doing like an IV piggyback and the 50 milliliters over 30 minutes. I wouldn't need it for that. All right. So looking at number 6, the order is for 5% dextrose in water at an IV at 125 milliliters per hour. The infusion set is calibrated for a drop factor of 10 drops per milliliter. Calculate the flow rate in drops per minute. I won't always tell you drops per minute. All right. Most of the time, it will say just calculate the flow rate. If you're given a drop factor, okay, then you're calculating drops per minute. So here we're given a rate, but the rate's the same thing as our amount and our time. Okay. So we're going to start with that. I want drops per minute. So I've got 125 milliliters per 1 hour times my drop factor, which is 10 drops per milliliter. Since my time that I'm given is in hours, I've got to use my time conversion, 1 hour, 60 minutes. And my milliliters cancel, my hours cancel, and I'm left with drops per minute. Now I can do one more cancellation. I can cancel the zeros, and I'm still left with a 6 on bottom. So I have 125, because 125 times 1 times 1, 125. 1 times 1 times 6 is 6. So 125 divided by 6. My calculator again. It's 20.38. 20.83. I looked at that and my brain just transposed those numbers. All right. So one thing, have y'all ever seen a partial drop? Now think about raindrops, y'all. You don't ever see a piece of a raindrop, right? It's kind of hard to do. So drops are calculated as whole numbers. Okay, our flow rate is going to be written as a whole number. So I can't use the 20.83. And depending on where you work, you can round it. They just want the whole. They don't worry about what the decimal is. So they would use 20 drops per minute. Now, some places want you to round it to the closest whole number. So in this case, this one would round to 21 drops per minute. Okay. I don't care which way you do it, if you just take the whole number or if you round it to the nearest whole. Okay. It doesn't matter. 1 drop per minute is not going to make that big of a difference. So calculate it, and then when you get into the hospital, or well, I guess it would be a hospital, or it might be a nursing home, I don't know. But wherever you're going to have to administer the IV, then talk to them about how they want to round it. So either one of these would work. You only have to give me one on the test or on the homework. You only have to give me one. I've got both of them entered as answers. All right, so number 7, we have an order of ampicillin 500 milligrams IV, 100 milliliters of normal saline to infuse over 45 minutes. All right, just like before with the infusion pump, I need to know there's 500 milligrams of ampicillin in my 100 milliliters, but I don't need this for my calculations. Okay, So I've got 100 milliliters, which is my total amount. 45 minutes is my time. Where's my drop factor? It's missing a drop factor. So what happens if you're missing part of the order? What are y'all supposed to do? Do what? No, go ahead and say it. I didn't hear you. Can't do, well, that would start it, but we can't calculate the whole thing without a drop factor. So how would we get the drop factor? Find my pen again. We're going to call the doctor. He's the only one that's going to tell me what the drop factor is. Okay, so you're going to call the doctor, ask for clarification. And I'm going to, since I did this, I was grading, I don't know if I was grading tests or homework or what I was grading, but the answer stuck out with me because I had a couple of them. If the order wasn't safe or something anyway, what would you, if there was a part missing to the order, what would you do? I think that was the question. If there was part of the order missing, what would you do? And I don't remember. I mean, I'm teaching 7 classes of this, so I don't remember which class it was in. They put, call the doctor, demand a legal written order because it's not legal if it's missing piece. Don't ever call the doctor and demand anything. Don't use a demanding tone with the doctor. They will get, some of the doctors, not all of them, you got some really nice doctors, but a lot of the doctors will get really agitated, aggravated. They'll get downright nasty to you. But you always call and ask politely, ask nicely. And I told the story this morning. My husband and I were in the ER somewhere. Anyway, and it wasn't our normal physician. It wasn't the doctor we normally use. So we were questioning a medication order he was giving us. And I knew enough about the order from this class to where it didn't sound right. So I questioned the doctor, and he looked at me and he said, okay. He said, where did you get your medical degree at? And I'm like, I didn't. I said, but I teach math for health professions, and I know enough about medications that it doesn't sound right. So I'm asking, please fill me in. And he just like, where did you get your medical degree? I don't have one. That's why I'm asking. So you'll have, even if you ask nicely, that's what they will do. So you've got doctors that have no bedside manner to the patient or to the nurses. My sister has gotten her butt chewed from a doctor before for calling and questioning an order. But you have to take it as a nurse because they've got the degree and y'all don't. So you've got a degree, just not the same as theirs. All right, so you've called the doctor, you've asked for clarification. The doctor tells you he wants 20 drops per minute. So you're going to write this as a verbal order, and then you're going to sign your name and whatever your degree is. Mine's MSM, Master's of Science in Mathematics. I don't know if it's actually an MSM. It is an MS degree. I don't know if it's an MSM. Yours would be an NS. If you had a Master in Nursing, it would be an MSN. But anyway, okay. So then we're going to calculate now. Drops per minute is what we're looking for. I'm thinking the girls on virtual are probably thinking she's crazy today. So I've got 100 milliliters, that's my amount, over 45 minutes, times my drop factor, 20 drops. Oops, it's per milliliter, not per minute, sorry. Drop factors are per milliliter. Do I have to do a time conversion on this one? I want drops per minute, right? And the order's already per minute, so I don't have to do a time conversion. I just have to cancel out my milliliters. Okay, I know something goes into 45 and 100 or 45 and 20, but I'm not going to worry about it because it's not easy to do. So 100 times 20 gives me 2,000. I'm going to divide that by 45. See, I only do the easy cancellations. If it's going to take me a while to do one, then I'm not going to do it. So it's 44.44. So how many drops per minute would I be giving? 44 what?
44, 45.
44, 45. Well, we could do that, but 40.44 won't round. So we're going to go with just 44 drops per milliliter. And I'm sure if you set it at 45, you'd still be okay. But just for this class, if it doesn't round to 45, it can give me the 44. Okay. Now I say that because that's what I want. But if you slip up and give me 45, I'm not going to count it completely wrong. Okay. So y'all are safe in that way. All right. So number 8 is yours. Okay. Y'all work that one and then I'll work it on the board. And remember, sometimes it gives you more information than what you need. And sometimes it doesn't. About 30,000 the first time. Yes, it is. Very good. So 31 drops per minute. So any questions? This isn't bad, is it? Now we did harder stuff in chapter 13. So, all right, I'm going to let you do number 9. So did y'all come up with 20 or 21?
I have a question.
Uh-huh.
Before I looked up, I had 3,000 milliliters over the hours. Can you explain that one more time?
Okay, so sometimes it gives you more information. The 3,000 in this case is the total volume, the total amount. And normally we would use that, but they don't give us a total time. But they give us the rate. So since they give me a rate that's so many milliliters per hour, then I'm going to use that one and not the 3,000. Okay. So go ahead and try 10. So we're all on the same page. Everybody get 50 drops per minute. When you have a drop factor of 60 and you have a rate or per 1 hour, your drop factor and your minutes are going to cancel and you're left with the total milliliters per minute, or per total milliliters, which would be your total drops per minute. Now on number 11 again, remember, because sometimes it gives you too much information. The 20 milliequivalents of KCl, is potassium, so it's potassium chloride per liter. That's the amount of medication per liter, so I don't need that. Again, this is my IV. So we're only going to do the 25 drops per milliliter, or 25 milliliters per hour, and the 60 drops per milliliter. Okay, so how many drops per minute did y'all get? No, not quite. Anybody else? Nobody wants to answer my questions. So if we use the 25 milliliters per hour, and then we got 60 drops per milliliter. Since that's hour, I've got to do 1 hour, 60 minutes. So my milliliters cancel, my hours cancel, and my 60s cancel. And that's going to leave me with 25 drops per minute. Okay. All right. So you don't always put just IV solutions through an IV. If you've got to give somebody blood, you're going to put blood through an IV, okay? So this time the order is for packed red blood cells. Somebody needs blood. And the doctor's ordered 480 milliliters to infuse in 4 hours. And we have a drop factor of 10 drops per milliliter. Okay. So I still want, it says calculate flow rate, but since I have a drop factor, it's still going to be drops per minute. So 480 milliliters. Y'all could do this one. I don't need to talk through it because it's just like the first ones we did. There's no trick here. I hit the wrong button. And I got 20, straight out 20 drops per minute. Everybody still okay? All right. So I made you work these the long way, okay? I want to give you the shortcut method now. Yes, ma'am. Okay.
So if it's in 4 hours, can we put like 60 minutes?
You can do 480, since it's 4 hours, do 4 times 60, which would be 240 minutes. So you can do 480 over 240. If you want to go ahead and convert the hours to minutes, you can, because it's just multiplying how many hours times 60. Or you can write it out with the conversion. There's the guy with the loud music, or the girl. It could be a girl, it shouldn't be. There's the person with the loud music. All right. Now, the shortcut method, mainly, well, it works with anything. No, it doesn't work with anything. It works with the drops per minute. And it's based on the conversion. No, hang on, what's my thing? It's based on the drop factor, how many drops per milliliter that we're going to give over a 60-minute time. And basically, you're saying to work these, it's 60 minutes divided by your drops, okay, per milliliter. So to get the 10 drops per milliliter, to get your drop factor constant, take 60 divided by 10, and that's where they get the 6. The 15 drops per milliliter, I'm going to take 60 and divide it by 15, and I get 4. For the 20 drops, I take 60 divided by 20, and I get 3. For the for the constant of 1, I'm going to take 60 and divide it by 60. Okay, so the rule with using these drop factor constants is you take milliliters per hour, and it only works when you're given the rate in milliliters per hour, or you're giving a total amount over 1 hour. And then it's over your drop factor, you divide it by your drop factor constant. I don't like this because I have no way of canceling out units of measure. So I've got 1,000 milliliters of IV ordered at 125 milliliters per hour, okay? This 1,000 is just added information I don't need because I've got to have the rate. My drop factor is 10 drops per milliliter. So my constant, if I could spell constant correctly, is 6, right? So using their formula, I'm taking my milliliters per hour, which means I'm just taking my number. So 125, I'm going to divide it by 6. I think that's 20.83. So 20.83. So I'm going to do 20 drops per minute, or 21 drops per minute. Okay. Some people like using the constant, the drop factor constant, using the shortcut. I don't have a problem with it. On the test, I won't, and homework both, I won't say use the shortcut method, and I won't say do it the long way. You'll just say calculate the flow rate, calculate the flow rate. You can calculate it either way you want. You can calculate using the long method that we've been doing, or you can calculate it using the constant if it's appropriate. So whichever way you want to do it on the homework or on the test. On the test, just make sure you're showing me what you're doing. All right, again, on 14, I've got the lactated ringers, 1,000 milliliters, but I've got the 150 milliliters per hour with a drop factor of 15 drops per milliliter. So y'all tell me, what is my drops per minute? My constant's 4. Yeah. So the constant is 4. But what's my drops per minute? $37 and $38. Okay. So have I confused y'all too much? All right, because Thursday I will confuse y'all. So Thursday we'll start with adjusting the IV flow rates. Okay. Any questions from anybody? Here, there, yonder? Girls, y'all okay online? Okay.
Yes, ma'am.
All right, good. All right. If you have any questions on your test or on your homework, let me know. I'm going to extend the test a few days because I know some people in the other classes were struggling with some of the homework assignments. I want to extend it a few days. So if you see the due date change, that's why. I mean, if I extend it for my morning class, I'm going to extend it for my afternoon class. All right. If you have any other questions, email me or come by and see me. And I will see you all Thursday.
That was it.
Bye.